Alright guys, we have a lot to cover this weekend. So we're going to be looking at solving quadratic equations using the quadratic formula. So you may remember the quadratic formula from Algebra 1. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this little formula here we can use to find the solutions to a quadratic equation. Before we can use the quadratic formula, we must make sure that our equation is in standard form. So we want to set our equation up like this. Again, we set it equal to 0 because remember the solutions are located on the x-axis and those points have a y value of 0. The next thing you need to be aware of here is the discriminant. The discriminant is this part underneath the radical, b squared minus 4ac. If this value, once you put the numbers in and you simplify it, if this value is greater than 0, then you have two real solutions. For example, x equals negative 1/2 and x equals 3. We have two solutions. If the discriminant turns out, if this number turns out to equal 0, we also have two real solutions, but those two real solutions are the same number. And when the solutions come out to be the same number, we have a double root. We also call that a multiplicity of 2 because we have two of the same number. Okay, and then finally, if the discriminant, if the number underneath the radical turns out to be a number less than 0, then we have two complex solutions. So for example, x equals 3 plus 2i and x equals 3 minus 2i. So can anybody tell me what these solutions are called? Just a little bonus question here. See if you remember. Okay, let's get to some examples of using the quadratic formula. So let's start off. Okay, we're going to go ahead and start it off right in standard form, so we're ready to go. We have our a value, our b value, and our c value. And we're going to go ahead and plug those numbers into the formula for b, a, c. Now, I highly recommend that when you plug the numbers in, so that you don't get confused, that you put the numbers in parentheses. It's going to help in some areas. So the formula goes negative b, which is 1, plus or minus the square root of b squared minus 4 times a times c. And this whole thing, the whole thing is over 2 times a. So now that we've plugged in all our numbers, before we do this, let's go ahead and start. I highly recommend you start by doing the discriminant first. So let's do this over here to the side. So 1 squared is 1 minus 4 times 2 is 8. 8 times negative 3 is negative 24. So our discriminant is going to be 25. Our discriminant is 25. So looking at our rules, 25 is greater than 0. So we're going to have two real solutions. And the solutions are both going to be distinct or unique solutions, not the same. Okay, so let's continue on here. So we have negative 1 plus or minus the square root of 25 over 4 Simplifying further, we have negative 1 plus or minus the square root of 25, which is 5, over 4. Now at this point, in order to get your two solutions, we're going to use these operations one at a time. So let's start off with the plus. Negative 1 plus 5 is going to give us the 4 over 4. So one of the solutions is 1. Now to get the other solution, we're going to use the minus. So negative 1 minus 5 is negative 6 over 4. And we're going to reduce this. 2 goes into each, so 3 halves. So the solutions, so the x-intercepts, the roots, the solutions to this equation is going to be 1 and negative 3 halves. Two real solutions. Okay, let's move on. That was example 1. Let's look at another example. Example 2. Here we have x squared minus 4x minus 4 equals 0. Standard form? Yes. Equal to 0? Yes. Okay, pulling out my numbers. A is equal to 1, B is negative 4, and C is negative 4. Plugging them into the quadratic formula, we get x equals negative b plus or minus the square root of b, which is negative 4 squared. Remember to put all of them in parentheses. Minus 4 times a times c over 2 times a. First thing we're going to do is we're going to do the discriminant. So negative 4 squared is 16 minus 4 times 1 is 4. 4 times negative 4 is negative 16. So our discriminant in this case is going to turn out to be, let's see what we have here, 16 plus 16, which is 32. So we're going to have 32 as our discriminant. Looking back at our rules, it's greater than 0, so we have two real solutions, two distinct solutions. Okay, so let's find out what they're going to be. We have a negative times a negative, which is a positive. Two times 1 is 2. So all I'm doing is simplifying this. I've already calculated the discriminant. Okay, next thing we want to do here is simplify the square root of 32. It's going to break down to 16 times 2, which is 4 times the square root of 2. So we have 4 plus or minus 4 square roots of 2 over 2. Now we have two terms at the top divided by one term. So we can break this up to 4 over 2 plus or minus 4 radical 2 over 2, because both terms are being divided by 2. So we end up with 4 over 2, which is 2, 4 over 2, which is 2 again, and then here are both of our solutions. So here we have 2 plus 2 square roots of 2 and 2 minus 2 square roots of 2. There's two answers right here. Now you can leave your answer like this. If it makes you feel better, you can write them out separately. So x equals that and that. And just so you know, since we have a square root of 2 in here, this means that these answers are irrational. They're real solutions, but they're irrational because we have a radical in our answer. Back here, our answers don't have radicals. These are known as rational solutions. Rational numbers. Okay, one more example. Example 3. I'm going to go a little quicker. This should be review for most of you. Standard form equal to 0. I'm not even going to label A, B, and C. Starting off, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. First thing we're going to do is find our discriminant. So negative 2 squared is 4. Whenever you square this number, it will always turn out to be positive. So be careful. So minus 4 times 3 is 12. 12 times 5 is 60. And so our discriminant is negative 56. Let's look at our rules. Negative 56 is less than 0, so we're going to have two complex solutions. Let's finish solving. 2 complex, because it's less than 0. So a negative times a negative is a positive. Two times 3 is 6. Now we want to simplify this. So the negative square root of negative 56 breaks down to, don't forget, the negative is the square root of negative 1. 56, let's look at our perfect squares. 4 goes in 14 times. Let's see, next perfect square is 9. Nope. 9, then 16. Nope. 25. Looks like it's going to be 4 and 14. Okay, so rewriting our answer here, we have x equals 2 plus or minus. And the square root of negative 1 makes an I. The square root of 4 makes a 2, which I'm going to put first. And then the square root of 14 goes last. This is my preference for the way to write this. And that's going to be all over 6. Then, just like we did before, we're going to break this up into 2 fractions. So 2 over 6 plus or minus 2 over 6, I radical 14. Simplifying, 2 6 reduces to 1/3, plus or minus 2 6 reduces to 1/3. And there's your two complex solutions. 1/3 plus I radical 14 over 3, and 1/3 minus I radical 14 over 3. We could rewrite it as one fraction. As well. So either answer would be correct. Now, make sure you look this over and make sure on Monday you come with any questions that you have. And I hope you're having a good weekend.